I'm Siddharth Narayanan. I'm a HPC research engineer at CONVERGE Science, and I work on porting CONVERGE CFDs to GPU using SYCL. So CONVERGE CFD is a fluid dynamics software, and it has a state-of-the-art physical models and multiphysics modeling. One of our main selling points with CONVERGE is our autonomous meshing and our capabilities to capture combustion in very fine detail. So with our version 5.1, we have a preliminary version of the GPU solver released with our CONVERGE package. So why do we go GPUs? So one of the major reasons why we needed GPUs, even for memory-bound applications like CFD, is that a lot of resources that are available out there today is GPU-based. Take Aurora, for example, is the latest supercomputer from Argonne, is a GPU-based system. So with that being said, we wanted to move our CPU-based code to GPUs, and since our code base is quite long, we wanted a framework to do the transition from CPUs to GPUs. We wanted certain qualities in our framework, primarily that we already have a CPU data backend. So we wanted the new framework to be minimally invasive. We want to introduce a little amount of code to port the code to GPUs. And we also want multiple developers to work concurrently on the porting process without having knowledge of whether the section before or after my section is ported or not. So that was one of our important things. And since we are a very large code base with a multi-year release cycle and a multi-year porting plan, we still want to have optimal memory transfers between the places where there is a CPU-GPU code sandwich or code interface. So we wanted optimal memory transfers. And finally, this framework needed to have minimal overhead, runtime overhead. So what we developed for that is what we call CAMTOF, kernel-level access-based memory transfer optimization framework. So we model a simple scenario here that could happen in a potential CPU-GPU conversion project, and we developed our framework to optimize for the number of memory transfers on those models. So we were able to show that around 43% memory transfer count savings in this naive scenario here, and we have an openly available implementation in our GitHub to have more details about that. And one other thing we did to help with the concurrency of the porting was to introduce automatic data transfer from CPUs to GPUs and vice versa. So that's also depicted here, and you can read more about it in our GitHub repositories. So now that we have the idea for the framework, we wanted to implement that, and we chose SYCL, vendor-agnostic C++ abstraction layer that lets us run our source code on all vendor GPUs. So SYCL is an open source project that's being developed by Kronos Group, and for the SYCL implementation we used was Intel's oneAPI DP C++ compiler with third-party plugins which support the Intel and NVIDIA GPUs. One aspect of SYCL is that it gives performance that's very close to the native backends as seen in the plots here. So with SYCL, it enables us to write a single source code that runs everywhere. So during our porting process, we had a bunch of bugs like how normally software development works, and we had a bunch of slowdowns. So we used Intel oneAPI tools such as Intel distribution for GDB, our vTune profiler, and finally we also used oneMath, which is a wrapper around oneMKL, cuBLAS, and RockBLAS. So we used Intel tools and SYCL to port CONVERGE CFD to GPUs, and now we have a single source code that runs everywhere.